of n. And that's what our outputs are for that. Now, for our paired sample correlations. The paired sample correlations, this lovely little piece, is the section this section shows the correlation between the two paired variables. So there are correlations is 0.096, and n is the same, obviously, and but mainly our correlation, the correlation coefficient is 0.096, indicating a very weak positive relationship between the variables. And then there's also our significance now. So the p-value 0.793, indicating the correlation is not statistically significant, which doesn't really help. Now there's our paired sample test. Our paired sample test right here is this section provides the results of the paired samples t-test. So the main thing that we really wanted, and it gives us all of that information. The mean difference. Okay. Alright, for our paired samples test, the mean difference right here. This refers to the average difference between the paired scores of the two related groups or conditions. In your case, or in this case, the mean difference is negative 82.6000, blah blah blah. A negative mean difference suggests that the first condition tends to have lower scores than the second condition on average. The standard deviation of the differences right here between the paired scores, it measures the amount of variation or dispersion among these differences in your data, or in the data, and the standard deviation of the differences is 5.48128. And next we're going to go on to standard error mean. This is the standard error association with the mean difference. It estimates the variability of sample means that would be obtained if the study were repeated multiple times. A smaller standard error indicates less variability and more precise estimation. Here, though, the standard error of mean difference is 1.733333. Now, when we go into the 95 confidence interval of the difference, lower and upper, this provides a range of values within which we can be 95% confident that the true mean difference between the paired score lies in your results. The 95% confidence interval for the mean difference ranges from negative 86.52107 to negative 78.67893. So that's the range. Now for t, the t statistics is a measure of the size of the difference relative to the variation in the sample code. It is calculated as a mean difference divided by the standard error of the mean difference. In your case, or in this case, this would be negative 47.654. Next would be the DF. The DF is, we've already talked about this, but is the degree of freedom. It represents the number of independent pieces of information available to estimate a statistic. For a paired samples t-test, df is equal to the number of pairs minus 1. So for this case, the df is 9, indicating there are 10 pairs of data points. Now, for the significance, so this is the p-value associated with the t-test. It indicates the probability of obtaining a result as extreme as the one observed, assuming that the null hypothesis, usually stating no difference between the conditions, is true. In this result, though, the p-value is less than 0.001, which means the observed mean difference is statistically significant at the 0.05 significance level. This suggests a strong evidence against the null hypothesis. But yeah. Now, if we head on down to the paired samples effect sizes, this section provides the effect. Right down here. Provides the effect size measures. So there's Cohen D's and Hedges correction. Cohen D, a measure of effect size, which is quite large, which is 5.48128, indicating a very strong effect. And Hedges correction, another measure of effect size, which adjusts the Cohen D's for small sample sizes. But if we want to go into greater detail, Cohen D's is a standardized measure of effect size that we already know, that indicates the difference between two means in terms of standard deviation units. It's calculated by dividing the mean difference by standard deviation of paired differences. And the point estimation for this case, or the point estimate for Cohen D is 5.48128. This means that the mean difference between the paired samples is 5.4812 standard deviations. And you can interpret Cohen D's values using general guides. A small effect would be around 0.2, medium effect is around 0.5, and a larger effect would be around 0.8 or higher. So for this case, 5.48128 is quite large, indicating a very strong effect size. This suggests that the difference between the pair samples is substantial. And so for Hedges correction, Hedges correction is a modification of Cohen's D that adjusts for potential bias when dealing with small sample sizes. It is particularly useful when sample size is less than 20. Hedges correction tends to slightly shrink the magnitude of Cohen's D to provide a more accurate estimate of the population effect size. Point estimate for the Hedges correction for this case is 5.99785. This adjusted measure takes into account the potential bias introduced by the small sample size. And the 95% confidence interval for Cohen's D provides a range of values within which we can be 95% confident that is the true effect size. Or it's where it lies. So the interview for Cohen's D was from -13.772 to -7.5 0.514. And for hedge correction, the confidence interval for hedge correction is not explicitly provided, but it would typically be similar to that of Const, adjusted for the correction. So, in all, our interpretation for the paired sample statistic shows that the mean score of the group is significantly different from the test score. Our paired samples correlations indicate a weak correlation between the group and the scores, which is not significant. The paired samples test, the negative mean difference, negative 82.60000, and the highly significant p-value of 0.001 suggest that there is a statistically significant difference between the paired scores, with the group having a lower mean score compared to the test scores. The effect size, both Const and Hedges correction, suggests a very large effect size, indicating that the difference between the paired scores is substantial. Yeah, and that covers the paired samples test. Now, for our independent samples test, we're going to be using the same group of data. So, it's in the same tab for our analyze, same tab and everything. Go down to compare means proportions and go to independent samples t-test. So right above the paired samples t-test. Now click on that, and once that happens, this little tab opens up. Whenever that opens up, you're gonna have your test variables for what the test variable is going to be. So for this case, for us, it's the score and the group variables. So how are they going to be separated, like what two different groups? So for us, remember that we had our group 1 and group 2 of students. So make sure to go into the group variable and click on that, and whenever you do that, you'll specify what the values of the groups that you're going to want to use and everything. And once that is done, then you click OK, or you click continue, and then OK, and then it spits out this output for your independent samples t-test. So alright, now for the independent samples t-test, so for this test, let's start off with the group statistics. This section provides the descriptive statistics for each group involved in the independent samples t-test. The group identifies the two groups being compared, coded as 1 and 2, and represents the number of observations. We've already covered this in each group, which is 5 for both group 1 and group 2. So since it's going to be split up this time. And the mean shows the average score for each group. In this case, group 1 has the mean of 83.6000, and group 2 has a mean of 84.6000. So pretty close. So you can see that it's pretty nice. And then our standard deviation indicates the standard deviation of the scores within each group. Group 1 has a standard deviation of 7.02140, and group 2 has a standard deviation of 4.27785. Yeah. And finally, for the standard error mean, reflects the standard error associated with the mean score, calculated as the standard deviation divided by the square root of n. For group 1, it is 3.14006. And for group 2, it's 1.91311. Okay. And so that covers group statistics. Now we're going to go into independent samples tests. This test assesses whether this is our main test, but then we're gonna get into Levine's test for equality of variances.